Okay, well, I hope you can hear me. And we have three people giving this it's sort of like a panel-like group keynote talk. I have Davin Fifield, who is the last to speak. He's a VP of Product Development at Oracle. We have Surend, Dayal, who's a partner at Deloitte and a senior lecturer at an Australian National University, and myself, who is sort of here as a coordinator and as a witness of the very early years of something. My very first job was working for a company called Softlaw, which produced a toolchain for automating legislation. And that eventually evolved into what is today Oracle Intelligent Advisor, or Oracle Policy Modeling is the previous name. And we are going to talk about the past, but we're talking about the past because it may be relevant to the future of many of the ideas and technologies being discussed today. So I'm going to kick off, and then Surend is going to kick in, and Davin is going to finish up with a demonstration of where things are at today. But I want to take you back in time. I'm actually going to take you back a long way. And we are going to look at the question. First of all, the abstract question. Hey, I want to do some programming language or a thing for the law. It's very much what this workshop is about. And one of the things that's most valuable to have in life is foresight. Foresight's a dangerous thing. There are many Greek tragedies which tell you that sort of story, but it's also the most important thing to have in life because it's even more dangerous not to have foresight. And when we look into the future, what happens when your thing, your idea, goes out into the real world, leaves the world of logic and proofs and the like, and heads into the future, into time and destiny and reality, practicality, a market, longevity, takes advantages of opportunities that are presented to that idea. Where does it go? And let's take back, and we're going to follow that story for a particular idea. And the idea was, let's do a tool chain for automating administrative law. And two people have this idea. Other people were also having this idea actually in Australia, though the context is not that important. Back in 1989, they were having ideas to build things called expert systems. Decision support systems, they were also called. There were various names for these things back in time. And then these ideas go through the forces of time, destiny, reality, etc., and on to today. And where does this take us? And so the evolution we're taking you through is from 1989 to 93. This is when I was involved. This is my first job, working employee number 3 at this little startup. That was literally in someone's garage, I should point out, back in the days when startups were literally in a garage, where this thing called the STATUTE inference machine and the rule-based workshop were created. Through to a suite called STATUTE Expert, followed by Ruleburst, which was also a different company or a new manifestation of the same technology into a new company, which was then acquired to become Oracle Policy Automation, and then is now rebranded or evolved to be Oracle Intelligent Advisor. And as things grow in the real world, they do change and evolve according to what the forces which they are subjected to. And something that starts within very legal roots, okay, evolves through to be something else. And let's talk about the origins. And again, what's the origins here? And this is absolutely crucial. You've looked at some of the talks so far about getting your law students and your computer science students to kind of work together. And then, what can come out of just two of those people coming together with a joint vision and a joint idea? We have one of the most exceptional administrative lawyers to come through Australia in the 1980s, 1990s. He was the author of the Annotated Social Security Act, a big, thick book that was the way of interpreting the Social Security Acts of 1988, 89. And that annotation would guide, his experience of having to both maintain that annotation and guide that through the future was a huge factor in leading to this immense amount of expertise in actually implementing administrative law in Canberra and that's no coincidence either, that this is being done in the capital city of Australia, where so much administrative law is actually being implemented at the time. And he meets David Mead, who's a very talented computer programmer, and they make this thing called STATUTE. And what was this thing? It was something for direct use by administrative lawyers. Crucially, programmers are out of the loop. The administrative lawyers and people trained in that area would be the ones creating the rules and maintaining those rules. And so it's targeted to maintaining legislation under change. And crucially, knowledge is represented throughout the system. It's an absolutely crucial decision right from the start, using a limited practical form of the English natural language. And Davin will have more to say about how that vision evolved over time. But those are the crucial things that underlay STATUTE at the time. They were really good fundamental decisions. And I can assure you it matters immensely that you embrace these kind of fundamentals right from the start when building this kind of system, because they will sustain you throughout your product or your toolchain or your language throughout many years to come. So I just want to connect sort of the point of view of the rule bases and sort of programming languages. So in this setting, you are authoring a rule-based application. That is the thing you're making. The program is a set of logical rules written in this limited natural language. There is a development environment. We call it an IDE. It's got various different names that help you build and maintain the program. And then there's, of course, a runtime engine. And the runtime engine knows how to do things like collect facts. Crucially, it knows how to do a very fixed, small, but crucial set of manipulations of this limited natural language. E.g., you can take something from a fact form into a question form or a kind of suppositional form, and then from the system, it's able to generate practical interviews. What question do we ask next to learn more? It can do decisions and reports and sort of the things that that have to come out of this system in the end. And then, of course, you have some deployment scenario into Windows or later the web, and Davin will have much more to say about this, how this evolved over time. But this was the era when I was involved in the creation of this toolchain. Now I will hand over to Surend, who sort of picks up the historical story. He came in to fix up the very first academic papers written on this, which are all referenced in the supporting material. And so over to you, Surend.
Thank you very much, Don. Am I able to share, or does someone else need to do that? You're going to keep driving, Don? You're on mute.
Yep, looks like it's good to go.
Yes, I will keep driving.
Lovely. All right. Thank you, Don. And yes, this is it's really nice to actually be here. And I see some of the familiar names in that past talk. Giovanni Sartor. Hello, Giovanni, if you're here. Some of the people from the original conferences on AI and the law, which sort of started back in about E7. And what we're going to show you here, actually, and those points that Don made on the previous slide, there's a citation later in the talk from a 1993 paper we gave to the International Conference on AI and Law, which went into those things and why, in particular, it is critical for the runtime engine and the authoring environment that you use a limited natural language. Like you don't actually try and solve the hard AI problem of the computer understanding the language, and that's really at the heart of this, what we called isomorphism at the time. So the key concept with isomorphism, and the reason why you need a form of natural language in the software, is so that there's a very direct correlation between the underlying source material. And this is an example from Australia. This is the in Australia, family tax benefit is a tax credit that a very large proportion of Australians receive. It's almost like middle class welfare. And you can see here that the rules, and this is the legislation itself, it's directly from the legislation. And then if we go to the next slide, this is the code. This is we called it the rule base. And this is and back in the day, I was one of the lawyers doing the rule-based coding. This is the code that you wrote to faithfully model that previous piece of legislation. Now, then behind the scenes, the inference machine and the engine can reduce all of this to, back in the early days, it was like almost like a prologue horn clause. Today it would be, I guess, a Bacchus now or some sort of formalism for expressing it. But the key thing is the rule author doesn't need to know any of that. The rule author, who is not necessarily a software engineer, can work in English. And that was the critical insight that I think David and Peter had back in the 1980s. And it's the reason I believe that Statute Expert was successful enough to actually kind of withstand the test of time and become a proper commercial product. If you could just go one more slide. Now, one of the other huge things in this space is that the rules are not static. They're changing all the time, particularly in welfare law. So every 6 months or so, there's a rate change at minimum. But even more fundamentally, whenever there's an election, pretty much the government throws some money at people and they come up with new policies, new rules, new benefits. So you have to be able to take those rules, apply a delta to them, and come up here with our legislation interpretation policy prime and our rules prime as the kind of modified version of those. And you get lots of versions of these over time, not just one. It's not static. So that's one of the other critical reasons why the isomorphism, we call it isomorphic both in terms of the language you use, but secondly, in terms of the structure of the rules. So the rules are actually structured in a way that is very faithful to the source legislation. So, for example, you get an amending act to the Social Security Act. The amending act will say, change section 32 from this to this, and you can capture that very faithfully in the underlying software. Next slide, please, Don. So we wrote a few books about this, and these really drilled into, well, if you're the rule author, what do you need to do? What's the best way for you to capture your rules faithfully, maintain your rules over time? And I think we've provided a full table of contents in the GitHub repository that Don has a link to on the,
that's right. That's right.
There's slide there.
Lots of screenshots available.
Yeah, so there's a heap of material there. Just moving on, as I said, the underpinning thing was that you use English and that you don't solve the hard AI problem. And that meant that you could automatically generate the questions and the negations, both for the rule author, but then when you deployed the rules into production, people, the end users, could interact with the rules in natural language. So it's like a really smart form, and I'm sure Davin will demonstrate that to us. And then the other big thing is this doesn't exist in isolation. Everything has to be integrated somewhere. And there's been a massive amount of R&D on that over the last 20 years, heaps of it driven by Davin. So I'll leave him to go through that. And then the last one for me, Don, is just right back in the early days, the first use cases we had for it, they were in deeply complex legislative areas. So non-fault accident compensation, social security entitlements, tax law guidance, government compensation claims, and you'll see in the later slides how that's evolved over time. All right, thanks, Don. Let's hand over to Davin now.
Okay, I'm going to stop screen sharing, and Davin, you take over.
Great. Okay, so this will be a bit of a whirlwind tour. It's a very deep product, as you've seen from Don and Surend's overview so far. We've been around for a long time doing this stuff. So there's a high degree of maturity and capability in the tool set that is available here. But I'll just sort of start out by showing you what's involved with demonstrating the product in action, and then we'll drop back into a couple of slides to sort of talk a bit more about the evolution. So for the purposes of this demonstration, I'm going to take a little bit of the same act that Surend mentioned earlier. I could have picked anything, but just this happened to be one that I picked up. So if you want to see the source of this legislation, you can follow this link. And you can see here there's a lot of rules in this particular Division 4B about how to calculate what's called the single income family supplement. And I'm going to show modeling some of this, and then I'm actually going to switch to a sort of another project I prepared earlier that has a bit of a deeper sort of modeling in here as well. So I'm going to pick part of this to start with. I'm not going to do the whole thing live because that would take quite a long time, but I'm going to pick a chunk of this and just show you how you would model this in the approach that we take with the tool that is called Oracle Policy Modeling. So, whoops, what did I do there? That's not what I wanted to do. So here I've got, this is the tool called Oracle Policy Modeling. It comes with the Oracle Intelligent Advisor product, and it's constantly evolving, new releases all the time. But I'm going to start from scratch and just show you this process of creating an actual functioning application that is built around some modeled legislation. So this is an absolutely blank project, nothing up my sleeve, all brand new stuff. And let me just take that source material that I selected over here and just paste it into this Word document. So in this version of the software, what we work with is actually documents. So Word documents, Excel documents, as Surend pointed out, the sort of the isomorphism, the reflecting the same structure of the source material is really key in the approach that we've taken. And the best way to do that for people that are familiar with the law and for writing legislation is to work in a document-based format. And so that's sort of the philosophy of the product at its core. So what I'm in here is I've got this policy modeling tab on in my Word, inside Word, and this gives me access to sort of my authoring capabilities in this particular version. There is another cloud-based version as well, but this one is sort of got the richer capabilities at the moment, so that's what I'm going to show. So, a typical statement in this sort of piece of legislation is working something out, right? So we're actually trying to work out whether or not an individual's annual rate of single income family supplement is nil in the first line of this. So I'm going to create what's called a conclusion. I'm going to say the individual's annual rate of single income family supplement is nil if, and I'm actually writing a rule at this point within the natural language form that Intelligent Advisor uses. So I'm going to basically just start writing these rules, and what will happen is that they will sort of emerge within the data model of the application that I'm building as I go along. So I'll show you what that means in practice. So I'm just taking these phrases that are actually within the source material, and I'm using them to sort of write these rules that are, basically if I were to look at these two things side by side, I can tell that they're doing the same thing. So I'm going to validate here, and no errors found. Switch over to my integrated development environment, policy modeling. So previously the data tab, if I'd gone to it, was blank, and now you can see I've got some things that that have started to appear here. So I've got my first my first error has crept in here. I've managed to use different names for these two attributes, so they're actually appearing twice. So if I do that again, come back over here, now you can see I've just got one. So the erroneous second one that had a different name has disappeared. So what's happened behind the scenes here is that it's actually looked at the names of those things. It's done a little bit of basic parsing. So this very first, the individual's annual rate of single income family supplement is nil, which is something I'm trying to prove with that first rule based on their income. It's actually worked out what the question form of that would be as well, and the negative form as well. So, is it nil or is it not nil? So it's got some basic parsing of English and other languages within here. If I just quickly interact with this, so there's sort of an automatic application being built up behind the scenes as we work with this. So you can see it can ask me questions. What is the main income earner's taxable income? That's my one input that it knows about. My goal will be to work out whether it's nil or not. And if I put in, an income within that range, it can show me that their family supplement is not nil because that's what their income is. If I go back and do it again and say, their income is 50,000, then it's going to say yes, it is nil. All right, so that's like the world's simplest possible rule. Let's go and do a few more rules, and I'm going to just briefly show you know, how you can sort of build up this chain of logic. So this second rule is about, you know, is going to apply actually in the other case, right? So in the case they do fall in this salary range, so I'm going to create another rule here. And this actual rule is basically saying, and this is sort of demonstrating what we feel is a key aspect of this, which is to really try and model the structure of the source legislation as faithfully as possible. So here we're actually saying that we're going to work it out. We can actually work out what their supplement is using this method below if they fall in that salary range. So I'm going to say, instead of is nil, I'm going to say is calculated by method, right? And I could, you know, use whatever verbose wording I wanted to here, but that's going to create, you know, a condition that says, well, I should be calculating it using this method below, if that's the case. So now I'm going to use what's called the rule assistant and show you how I can sort of build this up sort of a little bit over time. So each one of these steps is sort of calculating another step in the rule logic chain. So if I say, you know, the step one amount is going to be equal to the main income earner's taxable income. Whoops, managed to click off that. Let me try that again. Step one amount equals the main income earner's taxable income. So that's going to create a rule for the step one amount. So this sort of method that's in this legislation is actually calculating this up one step at a time. So again, I can do the step two amount equals, you know, the step one amount less 68,000. So I'm not going to do very many of these. I just sort of wanted to give you the idea of how this works. I'm going to do the next one as well. And so this is the step three amount. And that's going to be equal to the step two amount times 0.025. Okay. So if I validate again now, go back to my data model that's being built up as I do this, you can see it's actually, so my one input is the main income earner's taxable income. It's sort of building up this chain of logic as we go along, the step one amount, the step two amount. Then it's got goals, right? These are the things at the end of the logic chain that are actually going to be calculated. Not all of these tie together yet because I haven't finished modeling my rules. So I'm just going to show you two more things manually, and then I'll zip over to the one that I pre-prepared earlier. So, you know, it can get a little bit tricky to sort of tie together the way the legislation is written with the actual rules. So here's sort of an example of where I've got some rule about the provisional component. I've got another rule about the provisional component later on. This is sort of like an intermediate step within the calculation logic. So I need to sort of, you know, again, try and model this as faithfully as possible. So I'm going to say the provisional component is the amount at step three is what I'm concluding. And so I'm going to use that if, and, you know, the step three amount is less than or equal to 300. Okay, so that's the last rule I'm going to write. Whoops, what did I do? Yeah, I just put it in the wrong spot. So that goes in there. And the last thing I wanted to show is just, you know, as you get to more complex structures, then you've actually got the ability to sort of put in what we call a table rule. So here I'm calculating the actual provisional component, which is, you know, going to be used later down in some other rules. And this is where I need to sort of refer to, well, you know, I know that it's going to be, if the provisional component is the amount at step three, then it's actually going to be the step three amount that I conclude. So the way this rule table works is to say, you know, this is what I'm concluding. If this is true, then this is the amount. So just to sort of show you how that would play out, I can say 300 is the amount I'm concluding if, let's use my rule assistant again, main income earners taxable income is greater than 80,000 and the main income earners taxable income is less than or equal to 120,000. And then my last rule, I've actually got, I'm going to put in another line here, and this will give you an opportunity to mention something else about the way the rule language works. So this last one is doing a bit of a calculation. So, you know, by the amount that it exceeds 120,000, then reduce it by 1 cent. So, so again, I'll just take this phrase here and say, you know, if it's over 120,000, then do a calculation here of, you know, so for each dollar of the excess, so I need to subtract the main income earners taxable income minus 120,000, and take that by, reduce that by, so multiply that by 1 cent, and then take that away from 300. And then, another key point here that I just briefly wanted to make is that the idea of the sort of modeling the legislation is that one of the things that tends to fall out of this is that you find any mistakes in your legislation, which are actually quite common in going through this very sort of faithful modeling process. And in fact, although it is actually the case that the provisional component is the amount at step 3 will always be true if their income is less than 80,000, that may not actually be obvious. So, there's an otherwise case here that I'm not too sure. And we often find in modeling legislation that it's very helpful to have these sort of explicit capture of I'm not sure what happens in the cases that don't seem to be specifically covered by the legislation. Okay, so look, just one more quick demo of this. As you can see, I've got my data models being updated again. If I debug this again, reset this, it's just going to ask me about the income earner's income. So I can see all of these things are being concluded. It's showing me whether or not it is calculated by method or not, and it's showing me that sort of the different steps of calculating this. So this ability to generate an explanation automatically without doing any additional heavy lifting to make that work is a key part of the idea behind this as well. Okay, last but not least, just one more quick thing I wanted to show is, this is a very rich and deep rule language. So in fact, if we just quickly pop up the function reference for the product, you can see not only do we have all these capabilities in English, but in lots of other languages as well. And there is a rich set of capabilities. So lots of different logical operators, logical functions, comparison operators, numerical functions. So it's a very rich language that you can express in here. Lots of different rule functions, temporal functions, all sorts of different things. But the thing that I wanted to highlight in this particular version is in this sort of more complete version I built it earlier, is it does work with quantification. So if we go back to our original rules, to the original source material, it talked about how to work out whether someone is the main income earner, and this is basically got rules around whether you're a member of a couple, and things like who has the highest income. So I won't go through this in a lot of detail, but there are all these ability to count the number of instances in a collection of an entity, work with relationships. So here I'm setting the main income earner relationship by working out who has the highest taxable income. Again, faithfully modeling the source material. And if I just quickly run this to show it in action, then I can see here, let's say I've got 2 people in my household. I'm going to add myself and my wife. And it's going to ask me my income. Let's say it's 75,000. Let's say it's going to ask, am I the individual? Yes, I am. What is Diana's income? Well, it's 16.5, and it's going to give me a fully detailed calculation of how this is calculated, including substituting in my name and my wife's name in all the spots where they're relevant to the actual calculation. So that's it for the demo. And at this point, I will jump back over to the presentation and give a little bit of a brief sort of discussion of some of the capabilities behind the scenes here and how we arrived at this. So, and just brief time check, I think we've got sort of 5 minutes left to talk and then about 10 minutes for discussion after that. So I think we're okay. All right. So yeah, so Don gave a sense of sort of where we started with this, and sort of the journey along the way has been largely driven by sort of the practical applications that we've been trying to, that our customers have been using this for, and the so from the sort of the initial start of being able to work with these Boolean statements, actually doing quite a lot of sort of phrasing of the sort of the objects involved. Actually, progressively over time, we've actually made the parsing, if anything, less clever, and really just the sort of working with the absolute minimum amount of the languages that we're working with as possible. So as it evolved, we did add this in this sort of uncertain state, which sort of represents whether or not you've asked a question, but there's no answer available, or there's no way of actually determining an answer, which is different from the null state of, there really is absolutely no information about it at this point. We saw some of the pronoun substitution. We saw some of the automatic web interviews. Original versions were in sort of Ready Engine. As I mentioned, over time, parsing has been simplified, lots of additional rule functions, the ability to work with relationships, so both parent-child relationships and increasingly sort of arbitrary relationships between objects, so hierarchical relationships, something called temporal reasoning, which if you're interested, you can go and check out the documentation on that. This basically sort of adds another dimension to the data model that's happening behind the scenes, so that you can basically calculate the truth of a value over time. So it will sort of calculate it at all the different change points within your data as you apply it. So it's very clever bit of technology. And as each step of the way, being able to call these applications via web services, hook them in with practical applications, lots of connectors to sort of Oracle and other applications are available. So this has sort of all led to the evolution of the application. A big change was, adding support for other non-English languages. You want to be as simple as possible with your parsing to be able to support multiple languages, and so that was really only feasible because of the simplified parsing approach that was taken. Many-to-many reasoning, so being able to infer the existence of objects and relationships between objects based on logic is part of the product as well. Again, all done in a way to try and make it accessible to non-technical people. I think we've sort of succeeded in varying degrees. Obviously, with such a rich, deep language, you do need to get quite a bit of expertise in it to be able to take advantage of all its capabilities. But certainly, the guiding principle has always been it should be possible for someone that is not a programmer to be able to learn and work out how to use even some of these advanced concepts. And I guess, so to where we are today, we continue to evolve the product. We've got quarterly releases. We are still working on how to make it more accessible, with every release to sort of the non-technical authors, adding additional features like ordering and arrays in ways that are, intuitive to non-programmers, is part of that evolution, and moving to a completely cloud-based authoring experience that isn't actually built around the desktop tools is part of that as well. So that's a lot of information. I guess I guess that one of the key theses of this talk has been that, if you start out modeling legislation, the path that you end up taking is inevitably one that takes you on a journey where you, for practical, commercial, various reasons, end up being applicable to quite a lot of other use cases as well. And so although this started out being very much based around, sort of government legislation, policy driven, which is, if anything, probably the hardest use case to model because of the complexities involved. Over time, you can see that the, sort of the use case that gets applied to, particularly as it's acquired by Oracle, do broaden and become, if anything, wider, and able to deal with even some of the, other more simple use cases in the broad sense as well. So, a whirlwind tour.
Yes, Davin, thank you so much. I mean, this is also a bit of a panel discussion thing, and since I'm kind of coming from this from the 30 years ago perspective, and it's just amazing to get that update from my perspective. Also, Surend, from you, and all the methodological work that was done all the way through. I want to ask Davin a couple of questions to make it a panel chat. Could you go back a slide on the application areas? And I mean, part of the key premise to why these application areas are the way they are is it must be that you still need this isomorphism. Okay, now we can all get that for legislation. We know that legislation changes through the government. Does that sort of change under change of what, and what are the texts coming in? Okay, for medical devices? Okay, are you really talking about regulatory texts? And so you're talking about regulation all the way through, or is it internal policy documents? What are the English texts coming in? Are they internal policy documents, or are they government regulation?
Yeah, it's all of the above, and I mean, medical devices, there is legislation that governs how you are supposed to deal with defects that are reported. There are, then the manufacturers themselves come up with their own policy documents about how they are going to ensure that they comply with those, and those documents get written and maintained as interpretations of those as well. And so it is a combination. Even something as simple as a retail organization and how it calculates its shipping fees. There's likely to be some document internally that represents how they calculate those things, and so they having that isomorphism between that document and even if it's not isomorphic, even just having a document you can go back and refer to and share it with the business stakeholders and say, hey, look, here's a natural language version of it.
Yeah, have you ever got to a point in any of these areas where you've effectively closed the loop, where the Oracle Intelligent Advisor or OPM documents are the canonical source, which is referred to? I think Surend has a great diagram of this later in the legislative area, but I'm talking in the regulatory areas. Yeah, where you really close the loop so that at every stage in the whole process of deciding policy, that's what's being referred to.
Look, I mean, I think there are varying degrees of that. In practice, what happens is that that these are two very distinct arms of of most organizations, right? So governments are large administrative beasts, and the people building and writing the policy are usually not the people implementing it. And getting those people even at the same table is often challenging. So it's I'm not aware of any specific circumstances. Surend, I know we've done a couple of sort of trials of that sort of thing in the past, but I'm not sure if they've made the light of day.
I think that's Nirvana, Don. I mean, that's ideal. That's where you'd want to get to. But there's a big societal change required there, not only in government, but in the large corporates too. And you could certainly see the benefits of that, which is why we kind of came up with that integrated model, which I'm sure we're going to share with everyone later, the kind of the full cycle, the life cycle of the rules. Ideally, if everyone's working from the same model, you can kind of model changes to the model in advance and say to the government, well, what if we change the pension age? What's going to happen to the population?
So another thing that happens is that these legislative texts and also regulatory ones, they refer back to other legislative texts, and they kind of say they did modification upon modification, and the texts actually end up as kind of a set of deltas, which kind of refer back to previous regulation and the like. Do you? I mean, that's quite a hard kind of problem to get isomorphism in, because do you still try to follow that kind of structure?
It is difficult, and you try and follow it, but just imagine if you didn't have Intelligent Advisor, and
it's even harder,
and it's even worse. And people are just working in English, just working in Word, and the policy people and the legislative people are completely separated from the people who are implementing, who actually have to administer the legislation. It's like a really buggy piece of code with dangling references, things that don't apply properly. And we have used the software. One of the questions is, do we have a consistency check for the rule set, such as completeness, etc.? And yes, so heaps of that does come out of this process where, so for example, maybe 10 years ago, we applied it to help rationalize the tax legislation in Australia, which over time was had grown to 10,000 pages, but probably half of it was redundant because of all of the stuff that had happened over time.
Okay, so Davin, let's go to the summary slide, and we'll take questions from the people in the audience. So I just pop through the last two slowly. I think discussion summary. Okay, yeah. So we just put a couple of summary points. Toolchains for legislation that find widespread adoption. This is what Davin was speaking to. Eventually become toolchains for automating business policy. and that it's inevitable. Even in the early days of soft law and statute, this became very evident very quickly that legislation needed its interpretation, but not only that, it needed to be, when it's being automated, that means automating business policy. And then the second point is that toolchains for legislation must be grounded in a limited natural language. And the limited is key. And Surend is actually very insistent that there are several projects in the history which have tried to be too ambitious on the natural language front. But you can see here that a limited form of natural language is being used, and that you need to have some natural language. It has to be limited, and that is absolutely essential in all of these different domains.
Yeah, I think the critical thing there, which Davin alluded to in terms of doing the multiple languages as well, is the key thing there is to make it simple enough so that you don't need to be an expert in grammar to write the rules, but accurate enough that the software can grammatically correctly construct a question, a negation, pronoun substitution, etc.
Yeah, it's funny. It seems to me that for almost every logic that people come up with, there's actually sort of a manifestation in this limited natural language form, maintaining that isomorphism, right? Yeah. And that actually seems to be an underappreciated value add or process almost. It's necessary to be successul. For logical advancements that are so being discussed out in this kind of ProLALA kind of setting, you need to be able to just sort of almost automate that process of getting up to the English limited natural language kind of level, and that's always kind of a missing piece of the puzzle, which was always
and that's actually where I have thought about that'd be a great research area for like an AI type thing, because you could probably train an AI to do a lot of what a rule author does at the moment. It's possible, in that translation from the source documents, in at least a first cut, and then a human maybe goes and makes sure that it's accurate.
Do we have any questions from the audience?
At this stage? Yes, there are a lot of questions from the audience, so sorry to jump in.
That's so good.
That was a very well-received talk, so first a round of applause for the speakers.
Thank you.
Davin, maybe pop up the papers slide just so people can look at that while that's it. It's the primary references here back to 91 and 93, and there are lots of others in the supporting material. Over to you, Jonathan.
All right, let's start with the first question from the Q&A, which you should all see on your screen and be able to respond to.
Yeah, this is a great question too, I think. I might have a first crack at it because I have had this question a few times. The short answer is yes. I think absolutely. And it comes back to whether or not, particularly in the government context, whether or not the government wants to, how transparent they want to be with their rules. I remember when we did one of our first projects in the UK for HM Revenue and Customs, this question came up. Should we publish the rules? And my view is yes. The government at the time said no because they were worried that people would then game the system. But my feeling on that is that that's not a good reason to keep the rules secret. What you do then is you focus on whether or not the data that is given to the rules is accurate.
And the second part of the question, have we thought of open sourcing a reference interpreter? Yes, we have thought of it. How to actually go about that is something we haven't worked out yet.
Yeah, another great research area. People are up for it.
Okay, great. Next question. Yeah, and I must say that I have thought about that too. I mean, the language has such a regular structure that it just seems like you're providing a front end that feels very familiar and reassuring with the word kind of user interface. And what's your take on this?
So there's, I mean, the breed of user that is more comfortable with the tool chain is someone who has a logical brain, right? And so we have greater success with people that are not actually programmers using the tool set because they don't think like programmers, because it's not a I mean, it's more of a functional language, right? It's a declarative, this is true if these premises hold. So I guess the short answer, yeah,
it's not only that; it's what they're not doing, Davin. They're not abstracting. They're not creating functions. They're not finding commonality between bits of legislation and creating common functions between the two. And that's absolutely key to a programmer's mindset, is to abstract. And so just to continue on, just diving in there.
Yeah, just the last thing I'd say on that is that, and I teach this at the ANU, so every year we teach it in the law school. So we do a subject called AI and law, and in fact, Don, I'll probably send through, or to the guys, I'll send through the links to the ANU courses. What I'd say is there are two sides to it. The challenge that a conventional law student or policy person has is getting their head around things like temporal reasoning or arrays or many-to-many reasoning, those areas. They're very comfortable with the core policy stuff. The challenge that a software person has is understanding the policy rules. They're quite comfortable with many-to-many, time-based reasoning, all that kind of thing. And so, yeah, I think the ideal person is someone who understands the policy but has enough of a logical mind to be able to grasp the tool.
And so a follow-up question to that is whether you have a consistency check for your rule set. And I think that, yeah, the question that's just showing up on the screen, right? If the person is not necessarily a programmer, do you do anything to help them or to flag blatant inconsistencies in the input?
So the short answer is yes. There are lots of testing capabilities built into the toolset, but probably the most important thing is the methodology itself lends itself to driving consistency. Unlike most other approaches, you can't have multiple things proving the same outcome, multiple rules proving the same outcome. You can have a single rule. And so that sort of drives you to sort of flip your thinking around and say, okay, how am I trying to prove this thing? And bring together all the different aspects of that in a single rule, basically. So, but there are lots of testing tools as well. We do have rich capabilities in that area.
Okay. A slightly similar question from Fritz. He's asking, regarding the isomorphism principle, how do you reflect legal doctrines where a body of rules may result in multiple inconsistent results, which are then required to be resolved by doctrines? Which is the second to last question.
Yeah, non-monotonic reasoning. Yes, I remember this very well. Davin, you want me to have a crack at that, or you?
Yeah.
Yeah. So that essentially just means you write more rules to resolve the inconsistencies. And like in an ideal world, if you're working in an admin law area, you can actually go to the policy people who created the rules and tell them, because that's effectively a bug. It's like, okay, you've got these rules and they don't work properly together. On the other hand, you could go to the court or someone like that to resolve the inconsistency. That just becomes another rule.
One last question from online, then we'll do one question in the room, and unfortunately we'll have to do the rest of the questions in the chat. The last online question is a tongue-in-cheek one, and says, I have spoken with OIA vendors who say that they have given up trying to sell it to lawyers because lawyers don't want to be efficient. Do lawyers even deserve mistakes?
We were talking about this last night. It's like the turkeys shooting themselves for Christmas. So often lawyers are resistant. We did try, particularly in Europe, getting it into law firms, but they don't. Until the billing model changes, I don't think lawyers do want to be efficient. They charge by the hour.
I mean, just to clarify the definition of lawyers here, I mean, there are large administrative agencies around the world who do want to be efficient and who do have the ability to convince their system integrators that this is the way they want to do things. And they are reaping huge rewards when they do it. So in that regard, do lawyers deserve nice things? Well, yes.
But yes, to sell it to a law firm, different story.
And I'm going to finish with a story, since it's a historical talk as well, right back from the very early days of soft law, which was that the very people who founded soft law included in their original setup of the company soft law community projects, and their vision for making, the reason why they wanted to make statute in the first place was they had a vision of having booths where people could come and get cheap legal advice, that you could make the law so accessible and so cheap that anybody could get accurate legal advice for instead of having to kind of go and pay a lawyer. So really, right from the start, they had this and the software community project still exists today. I understand Surend is on the board. If maybe Davin, you are too, I'm not sure. So they had that goal of doing lawyers out of a job right from the early on, and maybe it remains a good job. They did the computer programmers out of a job. Maybe they in cutting them out of the loop, and maybe they can also cut the lawyers out too.
Okay, last question from the room, and then we can have the next speaker come up and switch.
Thank you. That was such a cool demo, and this relates a bit to the last question, but it's also a little tangential. In the Australian context, given that you have these sorts of tools available, why do you think that Centrelink, the government agency that handles social benefits payments, is steeped in such controversy?
That is a fantastic question, and I'll give you my cynical answer first, and then probably a real one. I think in Australia we actually have a reverse "not invented here" syndrome. So if the government here says, "I think if we invented it here, it can't be any good. We've got to get it out of Silicon Valley or Microsoft Research in Oxford, where Don is, or Cambridge." But I think the real answer is we still haven't kind of cracked Centrelink here. So they had this big controversy called RoboDebt, where they actually used a neural network type approach to do debt collection, which we're looking at trying to fix now.
Interesting. Yeah.
All right. Well, yes. I think we should wrap up. We're running nearly 10 minutes late. I just want to thank again the three of you for giving the keynote from different time zones, and a big round of applause for the three keynote speakers.